All right, guys, welcome to semester 2. We're starting off with Unit 5. So the first lesson in Unit 5 deals with these special right triangles. So by looking at the student checklist here, it says that we're going to be able to utilize 3 trigonometric identities, which you guys know, to find the side lengths of a triangle. You guys know how to do that, whether you remember it or not, but I'm going to jog your memory in this lesson. And the second thing we're going to be able to do is use a special right triangle, of which there are 2, to help me evaluate trigonometric functions without a calculator. So we're not going to be getting exact value, or I'm sorry, we are going to get exact values, but we're not going to be putting numbers into a calculator and just getting a decimal and rounding. What we're going to do is we're going to leave them exact. And you'll see what I mean by that in a minute. So we've got 2 triangles to start, and we're going to find the lengths of the missing sides. And before we do that, I'm going to tell you that this one is a 45, 45, 90 triangle, and this one is a 30, 60, 90 triangle. And what that means is that the angles in these triangles are, in this triangle, it's 45 degrees, 45 degrees, 90 degrees. And in this triangle, we've got a 30-degree angle, 60-degree angle, and a 90-degree angle. I've also given you one side. So I've given you a leg of each of these triangles. So with our 45, 45, 90, I've given you one of the legs. And with our 30, 60, 90, I've given you the smaller of the 2 legs. And we know this is the smaller of the 2 legs because it's across from the smaller of the angles, right? So this is the smaller leg. This leg, incidentally, should be the same length as this, and we're going to find that in a minute. So first, I said we were going to have to use our trigonometric identities, or our trig functions. So in order to remember our trig functions, usually we use this little acronym, SOHCAHTOA. And what this stands for, we have 3 trig functions. You have sine, which is equal to your opposite side over hypotenuse side, cosine, which is equal to the adjacent side over the hypotenuse side, and tangent, which is equal to the opposite side over the adjacent side. So if you need to write those down to remind yourself, go ahead and do it. But this is something that you should remember from 5th grade, 6th grade, 7th grade. Somewhere along there, they should have talked about those 3 trig identities. So what we're going to start by doing is using those trig identities to find sides of these triangles. So we'll start in our 45, 45, 90. Let's use tangent. We're going to say tangent of 45, and let's talk about this angle here. Tangent of 45 should equal our opposite side over our adjacent side. Well, our opposite side we do not know, and our adjacent side we know to be 1. So what we know here is that tangent of 45 equals x. So what we're going to do is we're going to use a graphing calculator, and we're going to go over to Desmos at this point. So in Desmos, or on my graphing calculator, whatever I'm doing, I'm going to find the tangent function. There it is. I'm going to be sure that I'm in degree mode because right now we're using degrees. The angle measure is 45 degrees, right? So I'll have to switch it over to degree mode. And I'm going to put in 45, and it looks like tangent of 45 is 1. So just as we suspected, the length of that far side is 1. All right, let's go over and do the same thing over here with our 30, 60, 90. We'll use this angle here, same angle, but this time let's use a different trig function. So let's find the hypotenuse. If I'm going to use cosine, that means the adjacent side over the hypotenuse side. So in this case, it's the hypotenuse we don't know. We have to get x by itself. So what I'm going to do first is I'm just going to multiply both sides by x, right? And what that's going to do is over on this side, it'll allow me to cancel those. And on this side now I'll have x times cosine of 60 is equal to 1. And now I can finally get x by itself by dividing both sides by cosine of 60. Okay, so 1 divided by cosine of 60 is going to equal whatever x is. So let's go back to our browser. All right, so again, I'm going to want to use my cosine function. But before I do that, got to make sure I'm in degrees. So I'll do 1 divided by, I want to use cosine of 60. And it looks like 1 divided by cosine of 60 equals. So back to our equation. Now that we know x equals 2, we've discovered that our hypotenuse, let's see, when the shorter leg is 1, is 2 in a 30, 60, 90 triangle. Okay, so we've successfully solved for one side of each triangle. Now what we'll do is we'll solve for the third side. And what I want to remind you guys of is that now that we know two sides of a right triangle, we don't need our trig functions anymore to find that third side. We could use them, and most people would say it would be easier to use them, but we don't have to anymore because we know two of the sides. One thing we can use now that we know two of the sides is the Pythagorean Theorem. Which is a squared plus b squared equals c squared. And don't forget, if you have to make a note of this, do. A is one of your legs, b is another one of your legs, c is always the hypotenuse. So now that we know two of our legs, or two of our sides rather, we can use the Pythagorean theorem to find the third side. So in this case, a squared plus b squared is going to be 1 squared, because that's one of my legs, plus 1 squared, that's the other one of my legs, equals c squared. We don't know the hypotenuse. 1 squared is 1. So what we've really got here is 1 plus 1 equals c squared, or 2 equals c squared. But I don't care about c squared. What I care about is c. So in order to get c by itself, just remember you have to take the square root of both sides. And in this case, we're only going to use the positive value of our square root because it wouldn't make sense for the length of our triangle to be negative radical 2. So the length here would be radical 2 of the hypotenuse of our 45, 45, 90 triangle. Now this is something you're eventually going to commit to memory. This triangle with these side lengths is very important in trig and comes up over and over and over again. So you will need to know that a 45, 45, 90 triangle has these specific lengths of sides and hypotenuse. All right, now over to our 30, 60, 90. Let's do the same thing. So we've got a 30, 60, 90 triangle. We do know one of the sides. We do not know the second leg. So that one's just going to stay as b squared, but we do know that the hypotenuse is 2. So a squared plus b squared equals c squared. That means that 1 plus b squared is going to equal 4, which means that b squared equals 3, and therefore b equals the positive square root of 3, which means that our longer leg is the square root of 3. And just like with that 45, 45, 90 triangle, this triangle now becomes very important as well. These two triangles are the only two triangles that I'm going to have you guys commit to memory, but these two are both super important in trig. So what we're going to be doing in class tomorrow is we're going to be using these triangle side lengths, and we're going to continue building off of this memorization of these triangles. It's going to be a lot of memory, committing these side lengths to this triangle, committing these side lengths to this triangle, and seeing what would happen if one of those side lengths changed. All right? So there's your first lesson. I'll see you guys tomorrow.